started writing it in the last 45 minutes, and like yeah, something like that. We never got completed.
Well, nobody solved this, to be honest. If we would have solved it anyways, pretty slim.
I just felt so cocky about, ooh, look at me, I'm going to solve the one problem that no one solved. I'm going to Georgia Tech, and then we didn't.
It looks like 14 teams got the first problem.
Yeah, that's the one thing to emphasize about ACM. This contest is kind of special, and that the problems are hard, but some of them that seem easy they are made difficult by the inputs that they give you. And their sample inputs in general are always really, really nice to you. If there's a special case, they're not going to give it to you. So if there's something that's going to break your code, they're not going to give that to you. You're going to have to guess that yourself. So, like in particular, I think that we had on Team A, we solved one. We had, I think, 4 problems that we had actually submitted solutions for, each of which ran for the sample data, each of which had an array of different errors, whether they be runtime errors, whether they be time limit exceeded, wrong answer. So the ACM is in general is not very nice to you about the sample input they give you. Go back to Alright, so while we're up here, any of y'all have any questions for us before we bring these other guys up?
Did you bring your balloons home?
Well, our balloon was completely deflated, so we did not bring it home. In past years, we've taken the balloon and tied it, like caught it in the door of the van and let it just kind of hit the van on the way back home.
See how long it lasts.
That's kind of the extent to which we cherish our balloons.
I still have ours.
I think at small college, I think it was last year, that instead of having balloons, we had little tiny balls. Which actually they were like rubber, and they had like different shapes and different colors for the problems, which was kind of neat in the sense that you could take them home, but not so neat in the sense that like people were like, oh look, they've gotten 8 problems, and there's like these little tiny balls sitting on the desk. So it's not quite so sad. Gotcha.
I mean, before you were in the February conference.
Commercial contest that time?
March. How did the Mercer Spring Contest help prepare you for the ACM?
All right. Well, I mean, the spring contest is good practice. So in terms of difficulty of our contests, we have small college and then the spring contest and then ACM. So it's nice because it's kind of a little intermediary between, and the problems aren't as difficult, but they are more difficult than small college, and the competition is better than at small college in general. So.
Hello everyone, here are the small college team A. So I guess we'll start with strategies for use of small college. As Chris mentioned briefly, ACM and small college are very different as far as styles that you use. ACM typically has much harder input data, much harder, some of the problems are a little harder, but small college is more about speed. There's not necessarily most of the problems you can solve pretty easily. It's just whether or not who gets it first, basically. Languages and references used. Language-wise, we use pretty much the same languages, I would say, as an ACM. Ours consists of Java, C++, and Python. I think Team B was it. Was anyone here from Team B? No. Okay. I think they just use C++ and Python. I believe. Oh, no, Tom used Java. So I guess both teams use Java, C++, and Python.
The major difference, though, is that in the small college competition, they use the newer version of Python, and at ACM, they still are using the Python too.
Right.
So that kind of caught up with the team.
And there are non-trivial differences between the two versions. So.
And as far as references used, we actually didn't use references in small college because it was kind of a speed competition. If we had to look things up, that would take away from problems we could solve. We didn't find there wasn't really any time where we were trying to decide which problem to do next. There was always something to work on the whole time. also, I meant to mention this, small college is only 3 hours as opposed to the 5-hour ACM. So you have a lot less time to work on things. So I guess we'll just jump right into Smile. I guess I'll talk about it. I think I can. Okay, is this ACM? Okay. All right, so there's only 8 problems. Okay, so here's Smile. All right, so basically you have one single string, and you find each case of a smile in it, which is a colon, a dash, and a open parenthesis, or closed parenthesis, sorry. That would be fine. That would be fine. So you find all the instances of that, and you print it out on the screen saying smiley count equals whatever that number is. It's a fairly simple problem to do. It's just a matter of basically finding it first, which is helpful. It's the first problem. But Wofford actually solved this problem in a minute, which we thought was pretty impressive, because they would basically have to read through this, read the input-output, and solve the problem, and know what to do for the problem, which you can actually solve this in one line in Python. I talked to a couple people about this. What we think happened is they basically jumped down to the input and output, prayed that there was no special cases up there, and solved the problem. Took a shot in the dark. And it worked for them, so good for them. I personally think it wasn't worth the, because in programming competitions, if you get a problem wrong, you get 20 penalty points, which is kind of the tiebreaker if you solve the same amount of problems, which usually happens in small college. So I personally think it wasn't worth the risk of getting 20 points, as opposed to the 5 minutes it would have taken to read the problem through carefully and solve it, because that's what we read it and went, man, that's really easy. And I gave it off to Steve, and he goes, yeah, that's really easy. And then we solved it. Just to make sure we didn't, have a 1-minute solution for a problem looking for smiley faces. So, I mean, the workful offered, so I'm not gonna, bash him on it, but it was risky, I guess. He could have easily just put one little thing in the top paragraph, and I don't think it would have been on it. But, yeah. So, yes.
You mentioned the night before why you were using a while loop for something similar.
Oh, that. All right. So, what do you want to talk about? Okay. So we had there was a practice session the night before where we can get used to the environment, and we had a problem similar to this. And we typically in programming competitions, there's usually you either have a problem that runs until the end of the file, or you have a problem that waits till you get like 4 zeros on a line or whatever. So just by habit, I always put a while loop in, and if there's not a special case, it just goes all the way in. However, this one was a single string of length in. So if you do a while loop, it basically runs an extra time through. And I messed up on that one. And Dr. and I saw this and got very concerned because this was the first problem in the set. But basically what happened, it read the line, and then there was the end of file character too, is what it would read, right? So technically it would read 2 lines. So it was very bad for me to do it that way. So when I saw this problem, I was like, oh, I should probably not do it the same way I did it last night. And I didn't, and we got it on the first try.
I have a question.
Yes, Dr. Allen.
It's almost like a clarification, and you didn't address it, but like some of the smiley faces have the original smiley as a subset.
You mean like,
Sideways.
You only have to look for one
oh,
smiley.
there it is. Are you saying like,
See sideways.
oh, you mean that? Yeah, yes, those don't count as
So
it's only,
You're just looking for that string.
So
Correct.
it is strictly substrings.
Yes.
You find that substring anywhere, even if it has the other characters around it that make it the other smileys.
right, see,
Okay.
that's something they could have added very easily, and then
Yeah.
Wofford would
So
have
it's 3 lines of job.
been wrong. So, that's one of the things. Yeah, so they could have easily done that. But yes, it only counts the 1, 2, 3. There, it's 4. Right, exactly. So, yeah, great. All right. All right, the next problem. Okay. Look and say. This next one. So, you want to talk about that one, Steve?
Sure.
Okay.
Well, look and say, I think we decided this problem was medium easy. It wasn't as easy as Smile, but it was not that hard of a problem. Although, like Levi said, at small college, it's all about speed, and this problem still took 20-30 minutes to solve. So, essentially, what happens is they give you a sequence of numbers, and if you were to like describe that sequence to someone else, you can see here, it's got this laid out. Well, that one was there. It's 1 1, 2 2s, 1 3, 2 4s, 3 1s. So within the sequence of numbers, you've got little runs of the same number, and you can group those numbers together. So if you have 3 3s, you say 3 3s. And what they want you to do is to output essentially the numbers you would say to describe the input sequence. So essentially what we did for this problem, we just had a loop, reading the input, and then run through the string, and it would count. I'm trying to think. You had one variable to keep track of which number you were kind of on at that point, and then another to keep track of the length of the run. So you would read in this one, and it would say, all right, our run length is 1, and the run type, you might say, is also 1. When you got to the 2, it would say, oh, we're on a different number now. So we print out the length of the run, 1, and then the run type 1, and then reset to the next run. It wasn't that hard of a problem. I think we got it.
The reason it took us we solved it 30 minutes is because we actually did the next problem between that. Not that it was out of order, we just Stephen came up with a pretty quick solution for it.
Josie.
Yeah, Josie. So we did that one second. But yeah, let's.
So did you have problems arguing over who would use the computer with 4 people on the team?
Not really. It seemed like as soon as one of us would finish an algorithm, the other team would be ready to go and debug something. And if we were kind of waiting on the computer, we just kind of probably had to go and say, can we come in right real quick?
Basically, the priority came to if you knew something was going to work or if you were trying stuff out. And trying stuff out, you got, like, if there's no one to code stuff, you can sit there and just try to figure stuff out. But if someone comes in and goes, I figured it out, get off. Get off. That was an important thing. You had to make sure that your teammates were respected. There were other teams going around where there was this team in our room, I don't know if you guys noticed this, he would not get off the computer. Like, he was just sitting there, no, I got it the whole time. And like, people in the hall were just getting furious about it because he would not get off the computer. So that's another important thing. You have to understand when you want to hold them and when you want to hold them. Oh, you're welcome.
I enjoyed it.
I thank you. All right. Do you want to talk about it? I know you talked about it. Yeah. Okay.
Okay. So Josephus. Josephus is kind of it's a game problem. It's kind of a game of hot potato. You've got a lot of people, and they each pass, I guess it's a rock, a certain number of passes, and then the person who ends up with the rock into that pass, they get out. And so then, close the gap and keep going. And I want to mention at this point, something people told me when I joined the programming team last year was they said, once you've done a lot of problems, you start referencing old problems all the time. You see something you've never seen before, and you say, oh, well, this is like that other thing I did. Well, part of the reason I think we got this problem so fast, I did a problem on topcoder.com one time that is, it's a harder version of this exact same problem. And so I saw this and I thought, oh, I understand this. And I could jump right in. I believe we solved this, it was faster than any other team.
17 minutes.
Was it?
Yeah.
This was the second problem we coded. And we did pretty well.
But yeah, it was very good. We got really excited when we saw one submit, one successful.
We had a lot of teams sending us an actual in class.
Yeah. So
You did.
No, we did not.
I thought we used derailers.
Yeah. Not.
They were doing pointers.
Yeah. We got. Yeah. All right.